and clear.
Okay, excellent. Well, I guess really the idea here today is just talk about some furniture-related items regarding SolidWorks. At the end here, I can, feel free to, like I said, ask questions as we go or save them towards the end. We should be able to, make this pretty concise, and be done here within the hour. But talking specifically about some furniture related design, maybe some different methods of thinking inside of SolidWorks. Obviously, some of you have used SolidWorks for a while. We can obviously build basic furniture and those types of things. You think of cabinets and drawers and all those types of furniture related items. If you're more advanced in SolidWorks, you can get into more complicated designs. One thing to focus on, though, would be a different approach to doing furniture, and that's using our technology we call weldments. And that's really what I want to show you here first. Let's open this guy up here a minute. So, if looking at like a dining room table design here, basically this end leg assembly here, maybe a different approach to modeling that using our weldment technology in SolidWorks. So if some of you aren't familiar with this, you hear weldments and you might think, oh, that's a machine design guy, that's a structural steel guy. We don't do any welding, is usually what people say. But again, it's really just a technology in SolidWorks. It's a functionality. So when we go into SolidWorks, basically a weldment functionality allows you to apply structural profiles, which is really just a sketch, which is customizable to another sketch. So I just kind of laid out the basic framework here of my table leg, and you guys can look at this, right? We can modify dimensions and all that. Okay, I'm not going to go through sketching 101 here. But basically, if I go into our weldment tools and go to structural member, what I've created here in SolidWorks is a library of wood profiles. So basically, this allows you to pick different things. So, when people think of weldments, they're probably thinking of, if I go to inch here, I can go to a C-channel or, an I-beam, that type of stuff, which doesn't really apply to furniture so much. So I've just created a library of wood profiles. So I can go into wood, I'll just pick a softwood type here, and then I have kind of your nominal, standard wood sizes here. So maybe this is going to be, maybe a 3x4 on the top and the bottom, and then basically you're applying that to the sketch profile in SolidWorks. You can do a number of things here. I can rotate the profile. So I want to stand it up on end. I can locate it differently. So maybe I want to locate it based on this point here. So you're essentially locating your three-dimensional extrusion based on a sketch line. You can do a number of things here. We can group items together. Again, I'm not going to go through necessarily everything that we might do. Maybe the bottom one is similar, though. So we'll rotate that guy 90 degrees, and we'll locate him maybe this way, just to be different. And when I hit OK, this is when it basically creates the extrusion in SolidWorks. I'm going to mute the phones here for everybody just so we don't hear our background noise. Maybe. Excuse me here, guys. If you have a mute button on your phone, if you can hit mute, that would be great. So we don't get some background noise there. But basically, you can continue to use this technology here to build other items. So if I want to go build the center structure here, we want to make it a 3x6, something a little bit different. And you're just kind of building this out. I'm going to rotate that guy 90 degrees. I'm going to locate him, be right in the center. And you're kind of building and laying out this framework inside of SolidWorks using what we call a weldment. If none of you have ever used this before, basically what we're doing here is we're building a part file inside of SolidWorks that's different bodies. You know, not knowing everybody's SolidWorks abilities, that's okay. You know, but basically here, this is not an actual assembly file inside of SolidWorks. It's actually a multi-body part. You know, so here I'm going to go and lay out these other members here, and I'm going to show you what happens with these guys, these cross members here. It's going to be 2 by 2, and let's just locate them right in the middle. Oh, excuse me there, a little rotation fun there. What's happening with these 2 cross members here, or 4 cross members, is the weldment technology doesn't know how to necessarily just extend these correctly. So what we actually give you is an additional tool here where we actually trim the bodies with respect to each other. So I can pick these 2 guys, for an example, and I can basically extend them to the space and choose which areas to discard or keep. Let's just pin this up here, so we do this a couple times. You know, so I do the same thing maybe down here in the bottom. So I'm going to trim down to the space again. And it's going to extend them or trim them accordingly you know, to the other extruded bodies. You know, and I'll do the same on the side here. Here's a good example where I might actually choose to get rid of this one, get rid of this one. So it's actually trimming these 2 to the side face here. Same on the other ones. You can kind of see the preview maybe on the screen where those structural members that I extruded, those 2 by 2s, actually penetrate into the center here. It's hard to see in a 3D solid environment. So that's why I'm trimming these back at this point to this particular face. So I'll go ahead and do that. And basically, you know, I have kind of this laid out inside of SolidWorks at this point. Now, a big advantage of using weldments here is the weldment functionality in SolidWorks manages what we call a cut list in the background automatically. So this is kind of an additional capability that's more difficult to do if you were just assembling each one of these pieces in a SolidWorks assembly. So if you look at the feature tree here, I can come over, I can do an update, and it's going to automatically sort the items that are exactly the same for me. So I have a running history, basically a running bill of materials or cut list directly in this weldment part. Coming along for the ride with that is a whole series of properties that you don't need to even control. It just does it for us. If you take a look at them here, it could be anything from the length of the items. If there's an angle cut on the end, so if I go to this other cut list item, which is the 2 by 2s here, you'll see the angle cut on the ends. This would be the overall length needed. You know, kind of the rough stock size, you know, the rough description, material. So a whole host of properties comes along for the ride when you do this, as well as a weldment part. Again, this is all dynamic. You know, what I mean by that is basically if I were to make an adjustment, like drill a hole through one of these or create a cut, it'll automatically sort this into its own item. So as an example here, I just have a sketch already created. Let's just go do a cut extrude, maybe through all, and accept that. And if I go back to my cut list and do an update, it'll sort that item out into its own body now, or own list item, since it's a unique piece in this example. So those are some of the things that we can do with the weldment tools. I think I have another cut down here we could do if you wanted there to kind of start shaping this thing up. So the use of weldments is you know, it's just a different way of thinking. You know, and I hail here in West Michigan, so we have a fair amount of furniture customers in West Michigan, and some of them are kind of adopting this methodology a little bit to laying out some quick basic designs. And this is great for cabinetry. Obviously here I'm using a table leg, but desktops and tables, those types of things people use this for. One thing that is worth mentioning as well is you can mix and match as well. So in SOLIDWORKS nowadays, we can have unique materials by cutlass or body, I should say. You know, so if these were actually like a stainless steel, you know, rod instead of a wood item in here, for more of a decorative piece, you know, you could still use your weldment tools to do that. You could still trim and extend them accordingly. SOLIDWORKS doesn't know that that's necessarily going to be, you know, a metal piece versus a wood piece. But you can actually go to that body in the feature tree here, and you could actually assign it its own material. I just happen to have this bottom body selected in this example, but I could actually go and assign that body a different material, even though I am not in an assembly environment. So some pretty unique things that you can start doing inside of SOLIDWORKS nowadays. So kind of on to the next point here. And one thing is we'll probably ask for you to send me an email at the end of this if you'd like. But I'm happy to share this library with anybody that's of interest to it here. So this library of wood profiles, it's just already done and created for you. So I'm happy to share this with anybody in the end who would like this. So just keep that in mind. Another nice thing, though, that a lot of people should start utilizing here, I'm going to kind of zoom in on this connection here, would be the use of library items or library features in SOLIDWORKS. I think the furniture industry is a great industry for using these tools in SOLIDWORKS. You know, you have a lot of maybe dowel connections, maybe cam locks, you know, kind of some unique ways to connect wood furniture that kind of conceals items. You know, think of like a drawer or a cabinet. You might have a dovetail or a box joint or something like that in the corners. You know, so all of those types of things could be saved in SOLIDWORKS as a library item. I'm going to go ahead and right-click on this face and just make it transparent. So you're actually kind of seeing inside this member here, just so you can see this functioning a little bit. Well, I'm going to go over to my library, and I have a series of library features I've created for the kind of the wood industry here. And let's maybe go to this tease here. Notice here it could be a biscuit joint, you know, this domino joint. I got some dowels here, maybe a lap joint, mortise and tenon. Maybe we want to connect this with some dowel pins though. Basically, the way this, and these can all be set up differently, however you want. But basically, here, maybe you want to do this 4-dowel joint here. It's a pretty big piece here. So I'm just going to drag and drop this into SOLIDWORKS. And basically, this little pop-up, hopefully you guys should be able to see here, is just trying to help guide me on what I need to select on the actual model to place these dowel pins. So it's kind of asking for the top right corner. It's also kind of listed over here. So I'll go ahead and pick this top corner point. It's asking for the end face, and it's hard to tell what's highlighting here, I know. But basically I need to pick this end face, so I'll go ahead and do that. It's asking for the bottom edge, so I'll pick the bottom edge. And then finally the top left corner point. So I'll pick that point. And you'll see a preview of my dowel pin showing up here. Again, this is why I made this transparent, so you can actually see this inside of the parts. But basically what's happening is a few things. It's creating cut extrudes in the two pieces to accept the dowels. And it's actually creating an extruded boss, basically, an actual pin body for the actual dowel. So it's doing a couple of things. And you can do some adjustment here. I think someone maybe just popped the question up where they couldn't see those features in their library. Again, these are custom items that I've created, so these are not out of the box in the library inside of the SOLIDWORKS design library. So these are things that I'm happy to share with you as well at the end of this presentation, if you'd like them. Basically, though, I can adjust a few things here. So I'm just kind of adjusting the length from the end. This here is the length of the dowels. Maybe I want to make it a little bit longer. the diameter. Maybe we want to make them a 1/2 inch. You can kind of see it's all dynamic here. Okay, someone's making a call there. Sounds like that went off there. You can even do some overriding of some dimensions and things here, which is kind of an optional thing here, which you can adjust the gap and the clearance and things like that. So, this would just be a gap at the end, if I made this 0.1 or something like that. If I hit OK, though, it's actually going and creating the cuts, like I said, in the SOLIDWORKS model. If I were to hide this part altogether, you can kind of see those pins sticking out the backside there. If I go ahead and maybe pull a section cut through here, so you kind of see everything inside there all at once. You can see where it's kind of created the cut extrude in the two bodies here, and actually added a pin part in the middle. So again, use of some of these library feature items. I'm not going to go through all of these that are here that I have in my custom library, but could be very useful to you guys in the furniture design industry. Questions to this point? Phone should be unmuted if you had a question. Okay. Again, these library items that I have a library here called Wood Library Features. This is not out of the box inside of the SOLIDWORKS Design Library. So this would be something that I can also send to you if you're of interest to you. One thing I'm not going to spend a ton of time discussing necessarily, but is drawings a little bit. The nice thing of doing these designs using weldments is that a lot of this can carry over into a drawing nicely. So, obviously we can detail a drawing here. I'm not going to sit here and do that in SOLIDWORKS, but basically this is a drawing I've already started on a finished product here. But basically here's the cut list that's basically I was showing you in the property information. This is all automated. I didn't have to massage this really at all. You can customize it just like you could a bill of material in SOLIDWORKS. So if you want a certain column for material as an example, we could add that column into this cut list very easily. So that's one thing we can do. The other thing a lot of people ask me about would be detailing individual pieces. Again, if you're a long-time SOLIDWORKS user, obviously, like I said, this is not an assembly inside of SOLIDWORKS. So how do I detail an individual piece out of the model? And there's really two ways to do it inside of SOLIDWORKS nowadays. One is if I just go to a blank sheet here as an example, if I were just going to insert a view of this item as an example here, I could go on and pick a particular view that I'd like to see. But what I have the ability to do is in the property manager over here, I can tell SOLIDWORKS which bodies I actually want to detail. So if I say select bodies, it'll actually bring me to the model, and I can say, oh, I would like to detail just this guy here, and go back, and it's really just giving me a detail of that particular body. And then you could just do your thing, right? Pick and do your projections, and we could go in here and adjust scales and those types of things accordingly. Okay? So that's one item that we can do for detailing. Another method is using what we call a relative to model view. This has been around for years inside of SOLIDWORKS. It's probably not on your toolbars by default. This is called a relative view. You might have to go in here under Insert, Drawing View, and say Relative to Model, or pull the icon out like I have here. It's basically the same thing that I just did, though. If I say a relative view, and I had a drawing view of a part as an example on my sheet, I just select on it, and it just brings me right to my particular model again. And the main difference is this. What I can do is I can say, well, I want to select just this body, and I want the front of that body to be this face, and I want the right side view, or whatever you want to pick here, to be this face. So I can actually orient this body however I want on the drawing sheet. So that's one unique thing that this does, as opposed to the first item that I had shown, is that I can specify the orientation of the body. So those are a few tips for drawings when you get into using weldments, you know, specifically if this is a totally new concept to you, because this always comes up. Well, what about detailing? What about detailing? And this is how I would go about detailing this type of a part in SolidWorks. Obviously, you can go and add dimensions and things like that to the model at this point. You know, what I like to use here, I'm not going to sit here and detail this beautifully necessarily, but what I like to use is just go into Smart Dimension and use the Dim Expert. Let's say I need a dimension from this corner, and just start picking items here, and you can quickly blast out your dimensions as needed onto your drawing sheet. Let me just move this guy up here. So, you know, very quickly you could have a fully detailed drawing of your body. Again, I'm kind of using the term body because that's what it really is in SolidWorks. You know, you might consider this a part, and that's fine. You know, it's really what it is. I'm just kind of talking like we would talk as it is inside of SolidWorks itself. Okay. Maybe let's look at some assembly tips and tricks here for woodworking. Yeah, let's close this guy down here, man. So here I have an assembly, which is really just an assembly of my two ends that these are basically already complete. How I was displaying it, I built those with weldments, just like I was showing you. I just have all the other detail on them, maybe. You know, same here, connected with these kind of cross members here. And obviously these pieces are put together as well. And basically, again, what I'm utilizing here is I've created a couple, again, custom items. And we're kind of taking it to the next level, not necessarily a library feature, but now we want to build some intelligence into an actual part. So this could be where, you know, I think of our good old ready-to-assemble furniture, right, and going down to the warehouse shop, grabbing that new desk, you know, for your kid to go to college in. We're going to put that thing together. And, you know, you got a bunch of the cam locks and stuff you're using, right? So basically, you could have that cam part, that cam lock as an example, as what we would call your library part, and we can attach intelligence to it. Now, I'm not using a cam lock specifically in this example. This is one that I always think of with the furniture industry. But here, I'm going to make this part transparent so you can see this a little bit better. Now, here again, we might have some dowel pins and things like that. But there's probably going to have to be more than dowels that hold this thing tight and snug against here. So maybe there's a threaded insert that goes into the leg itself, and then there's some sort of pocket on the bottom side of this part where you're attaching a bolt to tighten that into the threaded insert. You know, and you have to have a pocket in the bottom here so you can get your wrench in there to tighten that up. So what we can do is build intelligence into maybe that threaded insert or threaded rod that would go in there. And we call these smart components inside of SolidWorks. And basically it's just taking a standard component and building extra intelligence into it, okay? Now I'm not going to go into a lot of detail here as far as how we would create the smart component at this point. Maybe I'll look at the time when I'm done here and maybe briefly overview it for you. But basically, let me show you what I'm thinking here. One thing I've done is I've actually created lots of coordinate systems in this part. So I'm just going to display my coordinate systems. And basically the reason for that is, I've kind of run the gamut here of what we can do on a part in SolidWorks. Is I'm going to go over to my library, and let's go find my smart components. So I want to bring in this insert first, this hex insert. And basically I want it to align to my different coordinate systems on the bottom here. And I don't know if you guys are aware, but you can build in smart mates into your parts, right? So as I drag and drop them in, it's trying to automatically mate into position. And that's really why I'm using coordinate systems, is for the smart mating. So when I drag this component in here, when I get over top of a coordinate system, it just wants to automatically snap to that coordinate system. And this particular component has configurations. Let's just pick a size. And then basically what it's asking me here is if I want to align the axes of the coordinate system with the actual part. So I'll go ahead and do that. And I just insert this guy. I can go over here and do it over here, align axes, done. Over here, align axes, done. So just kind of thinking up front on how you build the smart mates, this intelligence into these components, is a useful aspect of using library parts. A lot of times people just, oh, it's a library part, and they just try to just drag it in there, and they're manually mating in position. Taking 5 extra minutes on that component can save you 5 minutes per part, maybe less than that, but mating the thing every time. And again, if you're not familiar here, I'm just going to open this guy up quick in its own window. Okay. Is all you're adding is what we call a mate reference in this component. Okay, and this has a coordinate system in it. Sorry, it isn't shaded here. There's a coordinate system right on the end of it here. And that mate reference here, if you don't know how to do this, just go up here to Reference Geometry, Mate Reference. And basically, if I take a look at this here, my coordinate system is my primary mate reference. That's basically why it's automatically aligning the coordinate systems. If I make this guy transparent again here, it's kind of hard to see, but basically this guy's sunken in to the leg part. Okay? And what I need to do here now is run the smart component aspect of that part. So what I can do here is select on it, and every time you see this little star, it's probably hard to see over the web, there's a little tiny star in the feature tree here on that component. That's an indication it's a smart component. Basically, I can select on that guy, though, and I can initiate this smart component dialog here. And basically what it wants to do is, every time I do it the first time, it tries to automatically insert it. Here we go. So basically what it wants to do here is just basically have me select a component to drill a hole. So this threaded insert has to have some sort of pilot hole, clearance hole in it, in the part, and that's really all it needs to do here. And SolidWorks is guessing the wrong component here. It's not supposed to be this component. I want it to be the leg. So I just go ahead and select the leg component, hit OK, and now you can see that guy a little bit better because there's a pre-drilled hole to accept that insert. So basically the intelligence here is the smart component is the insert, and the reason we call it a smart component is because it's automatically drilling a hole in the associated part based on the configuration in this particular example that I selected. Now, obviously we can go further from here, so we need to put in there's a threaded rod that goes in there. So again, let's go back to our library. Let's grab our threaded rod. Basically, it has a smart mate built into it to try to snap into position again, basing it on the coordinate system. And again, here, this is a little different. This is also using configurations, but it lets me specify the length of the rod that I'd like. So let's say I want 1.5 inches, and I'll hit OK, and it'll insert my threaded rod. Now, in this example, again, this is also a smart component, and here is where you really can see the power of this. Not only is this going to automatically add a cut kind of a clearance cut in the bottom of this cross piece, it's also going to add the necessary other hardware, washers, nuts, to the rod for me. So if I pick on this guy again, I just pick on the little star here to initiate the smart component dialog. Basically, this time it's asking me for a face. If I kind of rotate this guy upside down so you can sign here. So it's asking me for the bottom face where the cut is going to be created. So I'm going to kind of rotate this guy up here a little bit, pick this bottom face, and I'll hit OK. And just like that, let's make this guy untransparent again so you can see this better. It's automatically inserted this cut and the necessary hardware in the other parts for me. So again, this is another example of a smart component, but if you're always doing this type of a connection, why not spend the time to build this intelligence into your parts, your library parts inside of SOLIDWORKS? Again, this is more to show you an example of what we do. Again, I'm happy to share this example with whoever would like it. But these are some of the things that we can do inside of SOLIDWORKS for smart components and kind of specific to the furniture industry. Questions to this point for assemblies here? These are actual part files. If everyone's not familiar, if I actually do go and open this part file up, you will see that cut in that part file. So we are actually adding cuts into the part files through the assembly environment. Okay? And so you could obviously then go and detail this part out as needed. And we got here. Okay. So a few more minutes here, then we can maybe open this up for questions here. Let me go ahead and close this guy down here. While we're on this kind of topic of smart components, basically, in a nutshell, what you need to do to create a smart component is you're basically going to need to go ahead and create kind of what I call a dummy assembly. So you kind of create an assembly of parts that is kind of used to create these cuts and things like that. I mean, they're just kind of dummy parts, really. And then you just kind of make the component a smart component. You know, so as an example here, you know, if I open this guy up here, the threaded rod that I was using earlier, I can say edit this now in what we call the defining assembly. I call it a dummy assembly. It's really called a defining assembly, but nonetheless, if you actually look here, this will open up in the assembly. And it's just a block. Notice someone just created a block here, so you could go and create this cut. And basically, you just assemble the other components you want to include, such as the nut and the washers, and you go and create your cut extrudes as needed in this dummy block. And then you just make your threaded rod a smart component. You would go under Tools and be able to say Make Smart Component. And that's basically what you do. There's lots of other functionality that can come along for the ride here, but this is just one example of how it works. We cover in detail in our advanced assembly course, you know, more detail in creating smart components from scratch. So I'm not sure if anybody's been through that course in the past or not. All right, let's take a look at here. Let's just maybe look at one other thing, and then we can kind of open it up for some questions specifically. let's just open this little cabinet here. There's nothing fancy here, just a little nightstand. Obviously, again, we could be building this with weldments. We could be using library features, such as little dowel pins I was showing you earlier. You know, you kind of start getting into some pretty complicated items, though, if you'd like. Here I'm just opening up the drawer itself. And again, this drawer was made as a part file again, so it has a cut list, right? It's just created as a weldment part. You know, so it's kind of give and take if you want to spend the time doing a weldment functionality on something like this. You know, this is a pretty simple drawer example. But I'm going to kind of flip this thing upside down here and just kind of show you, again, these, here we're just using a box joint, nothing specific like a dovetail or anything. But what we could go in here and do is a specific, I'm just kind of rolling back in time here, is again, I have some library feature items here. Here we go to corners, box. Notice I do have some for dovetails, you know, lap joints, you know, miters, so some different types of joints here. And again, I can just share this information with whoever would like. But again, here I could just right hand, that's unusual there. But again, basically all I'm going to do is drag and drop this guy into SolidWorks. It's going to ask me some questions here, like pick the end face, you know, so that might be my end face. You know, the top inside corner, you know, that might be that guy there. The top side edge, that guy there. You know, the bottom outside corner, you know, to go and create my my joint here. You know, and you could adjust the width values and things like that if needed, you know, to space them out differently. You could probably go under here under size dimensions and give it a clearance. You know, so again, there's some different things that are set up here to adjust the the end joint, the end treatments here to put the box together. So, you know, we have a lot of those library features that I've created and played with. Again, some of these are pretty picky on how you pick things, but I mean, nonetheless, once you get the hang of the order, you need to pick things. It works really slick. You know, the other thing to show might be the even like the drawer bottom. You know, so maybe there's a bottom here. There's probably a groove created in these three parts here, and then the front of the drawer is assembled. It may or may not have a groove in it as well to accept kind of the drawer bottom. You know, even to the extent of that could be a library item if you wanted. You know, so let's see if I can figure out where did I put this guy. This little recessed panel here. You know, so again, I could drag this guy in. Do I want it indented or flush? Okay, and I can pick different things here. You know, face, you know, the inner corners, back and forth here. Let me pick these guys. Let's see if I screw this up. I'll probably screw this up the order here. Inner corner 2, back edge, and there you go. You know, there's a number of things happening here. Again, I can change some values. That's what's really cool about this stuff. You can build this in. You know, what do you want this to be? You know, 1/4 inch panel thickness. Maybe it's an 1/8 inch panel. You know, how much of a lip do you want on there? You know, 1/4 inch, whatever. Basically, it's creating the panel and the grooves in the part automatically for us here. So we take a look here in section view. You know, we can kind of see what's actually automatically being created. So with minimal setup, you know, a lot of times people don't think to the aspect of, hey, I need to create this. There's always a groove, or, you know, I have other ones here. You know, I always throw these hinges on here, so it needs to get an area rabbited or pocketed out. There's some wood screws or some screws that get added. And these are the types of things that could be built as library features or smart components. And that is what's really going to make, I think, for the most part, if you're just doing some basic, you know, wood furniture design, really fly and sing inside of SolidWorks. So, no pun intended, but kind of thinking outside the box a little bit in SolidWorks. So those are some of the main things I wanted to show you here. We're coming up on about 10:02, so I want to make sure to open it up for questions at this point. There's some other things I could have maybe showed, but you know, for the sake of time, I didn't, you know, maybe didn't get to those. But I'll go ahead and open it up for some questions at this point. You've been watching I've seen a few things chat pop up here. I can maybe address some of these at this point. The phone line should be open though, so feel free to ask as well.
Brian, this is David. We did get one question from Mike Hagan on the chat.
Yep.
Related to mortise and tenon.
Okay, mortise and tenon will overall length change on your bill of materials. It should, Mike, yeah. So I think when you're asking here is if you did like an actual mortise and tenon. I don't have that guy up anymore, but
what I was looking for is does that follow through with your drawing? So it'll tell you that like that those they weren't 45s, I think they were 38-degree pieces you had. Will that tell you the angle and how far up your mortise goes, as well as when you add features like that, will it change?
Oh, like on an angle? You're talking about if you add the mortise and tenon, like the angled face?
Yes. It appears that it would.
Yeah, it should. I mean, it should give you the overall length. I guess I don't know that I've ever tested that specifically on the. I could run the one that I have here and give it a go, but it should, because what the weldment technology is doing, it's always calculating what the longest length is of that body. So that's what that length parameter is, that length property is, and then get back to this guy here. And then the angle is obviously and that's going to be the angle on the furthest end as well. So your mortise and tenon angle should really be the same angle as your, you know, the miter initially was on the one that I was showing here, right? Yeah, so I didn't add one on this particular one here, but yeah, when we're talking about these properties up here, we're looking at some of these guys. Where's our? So here's one with the two angled members here. So when we give you this length property, this 13.71. And that's going to be your longest length. So that should be this length of this edge here in this particular example. But if you had a mortise and tenon, you know, sticking out the ends here, you know, the overall longest length should increase. And then the angle cut is whatever angle is on the very end of the member. So yeah, it should. You can test that. Get off the phone here.
Okay, Brian. Nathan has a question related to setting up a design library component. Is there a walkthrough or some other tutorial on how to do that?
It's a great question, Nathan. You ask. That's one thing that we don't do a great job in any real basic training class of covering well. Usually I'm pointing people into the help file. I know has a decent, you know, probably example there, but it's going to be pretty basic. You know, so not quite as complicated as some of these dowel pins and things like that. You know, so really it's probably a little bottom feeding. I don't have a great resource for you, I guess, is what I'm getting at. You know, usually we might have an old power user, but that's kind of why we at Fisher kind of try to set up the power user events around these types of topics and things that aren't as common. But if I find a good resource, I can blast the people on the webcast with that. There's got to be a better resource for step-by-step instructions. Basically, though, a library feature, again, is you're kind of creating a dummy feature. So let's say you just wanted a library feature of a cut, right, or a hole. You basically create a dummy block, put your hole in there, and based on how you're dimensioning that hole, and when I say dimensioning the location of the hole, is what SOLIDWORKS is going to prompt you for when you add the item into the library. That's how I'm picking this point, this edge, or that face. It's all about how you modeled the initial library feature. Yeah, what I'd recommend you do if I send these to you here, let me go back here real quick a minute, is a library feature is kind of like a part. Let's maybe go over here to, real quick, we were doing dowel pins earlier. If I right click on this guy and just say open, it'll open up in its own window here. And got some crazy transparency going on here, but that's okay. So again, just kind of two dummy blocks. This is the actual library. We call it the library feature part. And you can kind of look back through, reverse look at what they did here. So if you actually look at this library feature consists of a whole host of items. I mean, it's 4 dowel pins, so there's 4 extrusions in here. There's looks like a pattern of cuts for the holes, and there's a couple of sketches that are coming along for the ride. So all these things I'm highlighting here are actually the library feature, and I'm sure it's hard for you to see over the web. There's a little green L on each one of these guys. That's how I can tell that. So when you're going in SOLIDWORKS, let's say you created this in SOLIDWORKS, and now you want to make it an actual library feature, what you would do is just come to your design library and hit the Add to Library button up here. And that'll start the Add to Library, it's not a wizard, but command really, in the Property Manager window over here. And basically what you could do then is you would just pick all these guys in this top box. Where do you want to save it? What file type is it? And you can even add a little description here. And then basically hit done. And it's in your library. Now as far as how you position that, and like I said, it's all about how these were all created. Okay? And once you create a library feature, in the very top of the feature tree now, there's some extra folders here. One is references. And so here I can actually look at what those references are. Again, this is totally based on probably the sketches of these features. Again, that's a good topic. That's probably a good example of something we should be doing in the future at Fisher. It's just Library Features 101 or something like that. But you can kind of use what's already in the SOLIDWORKS design library, or if you guys want these, I'm happy to share them with you and kind of try to look back at how they were done. That's usually a good method.